Hello everyone, welcome back to Bytes of CAC. So today we will be learning about first come first served algorithm. So far we have covered shortest job first and both the primitive and the non-primitive versions of priority scheduling algorithm. So today our topic is first come first served algorithm. Now as you can see that in first come first served in the screen there are four processes A, B, C, D which arrive at different times, like A arrives at time point 0, B at time point 1, C at 3 and D at 4, and they have different burst times. Now when processes, in case of first come first served algorithm, when processes arrive, they are made to execute in the processor in the order they have arrived. So no burst time consideration or no priority consideration is taken into consideration while we schedule them in first come first served algorithm. Only the arrival time matters. So you can say that you just sort that according to the arrival time, and whichever is has come earliest will be executing first. So basically it's like a queue. Whoever comes first will be served first. So let's get started with the Gantt chart. So we start from the time point 0. So from time point 0 to time point 10, A, which is the first process to arrive, executes from time point 10 to time point 10 plus 5. The next process, that is B, executes, so from time point 10 to time point 15. Now at this point C will be executing. Now C will be executing from time point 15 to time point 15 plus 12, that is equals to time point 27. And at time point 27, D will be the next process to get into the processor, and D will be executing from time point 27 to time point 27 plus 2, that is equals to time point 29. So based on this, we know that the start time of A here is 0. B has started at time point 10, C has started at time point 15, and D has started at time point 27. So based on this arrival time information, wait time of A will be 0, since A was the first process to be dispatched to the processor, and A arrived at time point 0. So the wait time of A will be 0. Wait time of B will be 10 minus 1. So B started at this point. So 10 minus 1, that is 9, will be the wait time of B. C has started at time point 15 and C arrived at time point 3. So 15 minus 3, that is equals to 12, will be the wait time of C. And D has started at time point 27. D arrived at time point 4. So 27 minus 4, that is 23, will be the wait time of D. So we know that wait time is start time minus arrival time. So accordingly, this is the individual wait time of the processes. Now we are concerned about the turnaround time, which is equals to finish time minus the arrival time. So the finish time of A is 10, arrival time 0. So the turnaround time of A is 10. B finished at time point 15, arrival time is 1. So 15 minus 1, that is 14, is the turnaround time for B. C arrived at time point 3, finished at time point 27. So 27 minus 3, that is 24, is the turnaround time of the process C. And process D finished off at 29, came at time point 4. So 29 minus 4, that is equals to 25, is the turnaround time of D. So the average wait time, as you have learned from the previous lectures, the summation of these four divided by the number of processes, that is equals to 11, and the turnaround time in this case, here average turnaround time in this case is the summation of the individual turnaround time divided by 4, that is equals to 18.25. Now let's make a comparison between the first come first served and shortest job first. Now you might be asking that why I haven't made the comparison with priority scheduling. See, in priority scheduling, the processes come with a priority and that is not dependent upon the burst time or any other any that sort of a thing which we can compare. Like in shortest job first, the shortest jobs are first processed before the longer jobs. So in case of priority, a process with a very long burst time might be a high priority process. So that will be dispatched to the processor first. So you can't really make a comparison on that account. But in case of first come first served, the first process to enter into the system gets the CPU first. Whereas in case of shortest job first, you know that they are sorted according to the CPU burst time and the shortest process gets dispatched first. So see, in this case, so we have the four processes with the individual burst time, and since the primitive version of shortest job first is a different algorithm, so we consider that all the processes were introduced into the system at the same time, that is zero time point, and by some means the processes were ordered like this. So in first come first served, no further ordering of the processes will take place, whereas in shortest job first, the processing will take place. Like D will be the first process to execute, B next, A the third process, and C will be the last process to get dispatched. So according to first come first served, just similar to what you have seen in the previous slide. So from 0 to 10, A will be executing, from 10 to 15, B, from 15 to 27, C, and from 27 to 29, D will be executing. Whereas in case of shortest job first, D has a burst time of 2, so from 0 to 2, D executes. B has a burst time of 5, so from 2 to 2 plus 5, that is 7, B executes. A has a burst time of 10, so from 10 from 7 to 7 plus 10, that is 17, A will be executing, and at time point 17, C is dispatched. C has a burst time of 12, so from 17 to 17 plus 12, that is 29, C will be executing. So if we compare, A had to wait for 0 time units, B waited for 10, C waited for 15, and D waited for 27 in case of first come first served. So the average wait time is 0 plus 10 plus 15 plus 27 divided by 4, that is equals to 13. Whereas if we consider the average turnaround time, A finished at 10 in first come first served, B finished at 15, D finished at C finished at 27, and D finished at 29. So 10 plus 15 plus 27 plus 29 divided by 4, that comes to 20.25. Whereas in case of shortest job first, A waited for 7 time units, B waited for 2 time units, okay, D waited for 0 time units, and C waited for 17 time units. So that becomes 6.5 as the average. And average turnaround time in this case, let's start with A. So A finished at time point 17. Here it is. B finished at time point 7. Here it is. C finished at time point 29. This is it. And D finished at time point 2. So the average turnaround time is this divided by 4, which is equals to 13.75. So clearly, shortest job first is a winner in terms of both average wait time and average turnaround time. It's much better than first come first served, but still we use first come first served. Why? Because the biggest advantage is no starvation. Now if you have gone through the shortest job first lecture, I have shown you how the longer jobs starve in case of shortest job first, but no such scenario is there in first come first served. They wait for a decent amount of time before they are dispatched to the processor. I would highly recommend you to go through that video to understand the problem in depth. So I will not be discussing anymore in this lecture. So and the limitations, as we have seen, that this has a longer average wait time and longer average turnaround time. So that's all for today, because first come first served generally isn't asked as a direct question. Mostly they will ask you to compare between, say they will be giving you a schedule like this, and they will be asking you to compare between first come first served, shortest job first, or round robin on these average wait time and average turnaround time. So I will be discussing that. One I have discussed today regarding a comparison between a shortest job first and first come first served. I will be doing more comparisons in the coming lectures. So that was all for today regarding first come first served. So thank you for watching, and if you liked the video, please give me a thumbs up, and there's a link in the description box that takes you to a website that contains some MCQ questions regarding process scheduling algorithm, and I would highly recommend you to go through through the MCQs and find out how far you've learned. So that was all for today. Thank you.